This is exercise 45A in our textbook, where we're going to be constructing a confidence interval to try to estimate an unknown population mean. And just to preface this, in A, we're going to be constructing a confidence interval for private colleges mean. So I'm going to disregard any information that is provided here with regards to public colleges. So the question is as follows. College costs rise. An article on the CNN Money website gave the latest figures from the College Board on annual tuition, fees, and room and board. The average total figures are $34,132 for private colleges and $14,333 for public colleges. In an effort to compare those same costs in New York State, a sample of 32 junior students was randomly selected statewide from private colleges. So right away I can see I'm given some information about my state, and that is that N is 32. And then it also takes a sample from the public colleges. But again, Part A has me constructing a confidence interval for private college mean. So I'm going to disregard the public college. It says the private college sample resulted in a mean, which is a sample mean of X bar, equal to $34,020. Assuming the annual college fees for private colleges have a mounded distribution, which is like saying that the population is approximately normal, and the standard deviation, now they're describing the standard deviation of the population, which is my sigma, is $2,200. Find the 95% confidence interval, so my level of confidence is 95%. For the mean college costs, again, for private colleges. So there's step one. I've listed my parameters and my statistics in the state. In the plan, I want to check for three things. One, was the sample drawn randomly? Two, is it safe to assume that the different observations within that sample were taken independently of one another? And three, is it safe to assume that our sampling distribution is approximately normal? So one, was the sample drawn randomly? We were in fact told that it was a random sample, so we can check that off. Two, in our plan, is it safe to assume that these observations have been drawn independently of one another? I think that's a safe assumption as well. Three, is it approximately normal? Well, the sampling distribution will be approximately normal if one of two things is true. Either the population is approximately normal or the sample size is large to be able to assume that the sampling distribution is approximately normal. Well, both of them are satisfied here. We don't need both of them to be satisfied, but in our case, both of them are satisfied. N is in fact greater than or equal to 30, and the population is in fact approximately normal. So the plan is complete. We've checked for randomness, independent observations, and can our sampling distribution be assumed to be approximately normal? So part 3 is the do. And we looked at a formula in class today that has us constructing or calculating the do. And this is the formula we looked at. We need to take our point estimate, X bar, and add and subtract our margin of error. And we learned today that our margin of error is determined by taking the critical value times the standard error of the mean. That's called our margin of error. Well, using the methods we learned about in class today, we're going to estimate that for 95% confidence, which is what's given to us here, in a normal curve, we have to go out about 2 standard deviations. In class tomorrow, we'll learn how to be more specific, but we'll go out about 2 standard deviations. So our Z star here, or critical value, is 2, because we know 68% or about 68% of the observations in a normal distribution should be within 1 standard deviation of the mean, 95% should be within 2, and 99.7 should be within 3. So we want 95%. So our Z star in this case is equal to about 2. Our standard error for the mean is found by taking the standard deviation of the population, given to us in the stem of the problem, 2200, and dividing by the square root of our sample size, which would be the square root of 32. Our point estimate is our sample average, and our sample average for the private colleges was $34,020. So we're going to complete the do by finding the lower boundary of this confidence interval by subtracting and finding the upper boundary of this confidence interval by adding. So I'm taking 34,020 minus 2 times 2200 divided by the square root of 32. And I get the lower limit of my confidence interval equal to $33,242.18. My upper boundary is found by taking 34,020 plus that margin of error, and that would give me a value of $34,797.82. So there's the lower limit and the upper limit of my confidence interval intended to estimate the population average for private colleges. So now the question is, how do we interpret this value? We interpret this value by using our generic interpretation.